What's up, everybody? Welcome to the weekly live stream from Scalar Learning. And once again, we are continuing the trend of solving SAT Khan Academy problems live. And today we're working on manipulating quadratic and exponential expressions. So just doing a quick sound check here, making sure everything is working correctly. And then once I know that it is, we shall begin. And if you guys like what you see and you guys are indeed preparing for an upcoming SAT, make sure to subscribe. And if you like this particular video or like the way I'm solving problems, make sure to click like, add a comment if you have any questions in the link below. All right, I think we are good to go. The audio's working. Okay, let's begin. So again, I'm seeing these problems for the first time, which is always part of the fun. Never know what's going to happen. Let's begin manipulating quadratic and exponential problems. All right. The path of an atom where x is the east coordinate in millimeters and y is the north coordinate, okay? X and y in millimeters from a sensor is this equation. Among all points along the atom's path, what is the smallest east coordinate in millimeters? So this is basically like we're finding a minimum. Gosh, what my assumption is it's kind of like a parabola like this, right? Because it's flipped, right? If this was y equals whatever. And so the way I would think about it is what we would be trying to do if they said what is the minimum path in terms of the north coordinate, we'd be finding this point, which is the vertex, and we'd be finding whatever that y value is here, and that would be our minimum. But now they're saying, now it's kind of like flipped, it's going this way, and we still need to find this point, but we need to find the x value right here. We need to find the x value that is going to be at our minimum. Well, the way to do that, if I had a regular quadratic equation, I would be putting this in vertex form and finding that minimum, so I'm going to do the same thing here. I've never seen an exact problem like this where they flipped everything. I mean, this is a pretty tough question. I think it would throw a lot of people for a loop. I think that's the way to approach it, so I'm going to try it that way. So what we're going to do is we're going to complete the square. Y squared minus 4y. This means we're going to take half of this second term and square it plus 4, and then we still have the 5 out here. So I'm going to kind of group these together. We still have the 5 out here. Since I'm adding a 4, I also have to subtract a 4 to balance everything out. All right, and there's a reason why I'm doing this. I'm going to show you in a second. This becomes a perfect square. This becomes x equals y minus 2 squared. So basically what this factors into is y minus 2 times y minus 2, and then it goes to y minus 2 squared like that. All right, and then this subtracts to become 5 minus 4, which is just 1. All right, so now we have this new equation like this. And now we can see where the minimum is, or the vertex, which is the minimum in this case. And the vertex is at 1, 2, okay, for x and y. Now, normally it would be the other way around if we had an equation where we would have like y equals x whatever, right? Normally we would have it the other way around. And this value would correspond to the y value or the x value, etc. But because it's x equals like this, it should be in this format. So what this means is if we have a graph, the graph of this roughly, I believe, should be at 1, 2, here's the vertex, and then like this. And so that minimum value, that smallest east coordinate in millimeters, should be 1. Let me just make sure I'm going to read it one more time. The path of an atom where x is the east coordinate and what? Yeah, so I think that's correct. Let's put it in and see if this is actually right. Yeah, it is. And I just want to see how they did it. Yep, same exact way. Put it into vertex format, y squared, y minus 2 squared plus 1. Perfect. All right. That was definitely not an easy question. Question number 2. An intermediate chemical is formed during a chemical reaction. Assuming the mass is positive, the mass of the intermediate chemical M in grams t milliseconds after mixing the initial chemicals is given by this. According to the model, how long in milliseconds, okay, so let me read this again. An intermediate chemical is formed during a chemical reaction. Assuming the mass is positive, all right, the mass of the intermediate chemical M in grams, okay, here's the mass in grams. In grams, T seconds after mixing the initial chemicals is given by this, all right. All right, so this is its mass, and this is what's going on. T seconds, okay. According to the model, how long in milliseconds did the intermediate chemical have positive mass? All right. So we basically need to find the point at which this goes to 0. But now there's two values. So hold on, let me think about this for a second. Because at T, so when T equals 3.68 and when T equals 7.58, this thing is hitting 0 at both of these points, right? Because at 3.68 seconds, this whole thing goes to 0, the mass equals 0. And then at 4, let's say, okay, let me see what's going on when we're going to have this negative 18.79. And then let's say this were between 3.68 and 7.58. So I'm just going to say 4. This thing, I'm not going to go with the specific values. This thing will be a positive value. This thing, 4 minus 7.58, would be a negative value. And we'd have a positive mass. And then when it's 0, oh, I see. So when it's less than T, this thing has a negative mass. This is strange. Milliseconds, how long milliseconds is the intermediate chemical? Oh, I get it now. So it starts having, assuming the mass is positive, the mass of the intermediate chemical M. Okay. So it starts off negative. So it's when this is 0, at time 0, this is negative, negative, and negative, meaning the whole mass is negative. It doesn't flip into positives until we hit 3.68 seconds. Once we're in above 3.68 seconds, it's going to be positive, and then once we hit beyond 7.58 seconds, it again goes to negative because this value becomes positive. Like let's say if it were 8 seconds, this would be positive, this would be positive, and this would be negative. So it'd be, again, a negative mass. So it's within this time frame that it should have a positive mass. So they said how long. So what we can do is we can just take the difference of 7.58. This is a calculator problem, but we'll just do the subtraction like this. 4, 18. Oh, I'm sorry, I didn't need to borrow there. 0, 6, 15 is 9, and 3, 3.90. So something like this. And I don't think we need to say 0. Let's just put 0. Okay, let's see if this is correct. All right, it is. Yeah. Okay, cool. Question number 3. The function P below models the population in millions of Bangladesh from 1960 to 2010. So this is the population, and this is the number of years since 1960. So 1 would be 1961, 2 would be 1962. Which of the following equivalent functions displays the percent change in the population over the course of a decade as a constant or coefficient of the equation? So let's see. As a constant or coefficient of the equation over a decade. So let's see. So this is still the starting point. All these guys have the same starting point. And then now we're talking about every 10 years. I think if we put it like this, 1 point. All right, let me think about this for a second. So which of the following equivalent functions displays the percent change in the population? So this models the actual population. And so which of the following displays the percent change in the population? And so now we should be... Now, if we're talking about a percent change, the thing that's throwing me for a loop is we should be dividing by the starting point, right? Because it should be the percentage up from the previous decade or from the previous year. So let me read this one more time, make sure I'm getting it correctly. Which of the following equivalent functions displays the percent change in the population over the course of a decade? Oh, the percent change as a constant or coefficient in the equation. Okay. Well, it looks like I get what it's saying. So it's going up by 2.2% every year. And if we go, so let's try and use a calculator here. So 2.2, let's do it like this, 1.022 to the 10th power is, so this means it's going up by 24.3% in a decade, right? So I think I'm obliged to choose this one right here. Man, this is a tricky problem, but I think that's the percent change. And when we actually raise this 2.2% up and you carry that out over 10 years, it amounts to a 24.3% change, positive change. And so they said, which one shows this percent change as a constant or coefficient in the equation? This is the only one where I see 24.3. So I'm going to go for it. Let's see what they actually say. Yeah, that's it. Let's read their answer just because I want to see. Yeah, so they did the same thing. The power of a property of exponent says, let's use that property to rewrite our expression. So they're turning it into, okay, so they basically raised this to the 10th power, and then they divided t by 10. But anyways, that was the point, is they got the same value, this 0.243. Okay. I gotta tell you, these are super hard questions in my opinion. I definitely think these would be at the very end of the section, if at all, even showing up. When I took the actual SAT, I don't remember anything this tough. Okay, plane is traveling between the Hawaiian islands of Kauai and Oahu. The altitude in miles of the plane at a horizontal distance of x is given by this. So this actually is a quadratic. It's going to form a parabola like this. Actually, hold on. What is the maximum altitude? Again, we're trying to find the vertex. All this means is we're trying to get this into vertex normal form. So let's reframe this like follows. I'm going to first put the x squared term in front, 0.0014 x squared plus 0.14x. Okay, then before we can do anything, we need to factor out this coefficient. So we'll say negative 0.0014 times x squared, and then this becomes what times this will give us 0.14, and I believe it's 100. 100x, because 100 times this moves the decimal place 1, 2, and it's a negative to get us a positive, so minus 100x. Okay. And then I need to complete the square within here. So let's do that here. So now it's negative 0.0014 times x squared minus 100x. And then we take half of this value and square it. Half of 100 is 50. Squared is 2500. But now we also need to keep this balanced. We're adding a 2500, but we're actually not adding a 2500. We're adding a 2500 times negative 0.0014. So 2500 times 0.0014, this is negative, is 3.5. So it's a negative 3.5. So since we're really adding a negative 3.5, we need to add a positive 3.5 out here to balance that out. And then finally, we can rewrite this as, this is simply x minus 50 squared plus 3.5. And they want the maximum altitude. We actually already found it. This is the y value. This is the altitude. This is at, and it reaches this maximum altitude at 50. What is this? Is x is, oh yeah, horizontal distance. So when it's 50 miles away, it reaches a max altitude of 3.5 miles. So let's see. Hopefully this is correct. Oops. All right. Perfect. Let's go on to the next problem. Last one. A particular medicine is taken orally. Its concentration in the bloodstream is C in milligrams per liter T. Minutes after consumption is measured to be this. All right. The medicine enters the bloodstream as soon as C is not negative. How many minutes after consumption does the medicine enter the bloodstream? All right. So, I mean, this is really basically the same thing. It's a negative it's a parabola like this. We need to find when C becomes positive, okay? And the way I believe, so what I think this really is all about is this basically has 2 x-intercepts is the assumption because it's an upside down parabola. We actually don't need the vertex here. We need the x-intercepts. So we can, I'm gonna write this as follows. C equals 121 minus t minus 18 times t minus 18. Okay, the reason why I'm doing this is because now we don't want, it's kind of in vertex form. We don't want it in vertex form. We don't care about the vertex. We want the x-intercepts, or in this case, the t-intercepts. So I'm going to actually FOIL, and then I'm going to combine everything and then try and refactor, see if I can refactor. So this would be 121 minus, I'll put this in brackets, t squared, right? Minus 18t, which would be minus 36t. And then plus, this is a calculated problem, it's 18 times 18. I can't remember that. 18 times 18, 324. Plus 324. So now I'm going to distribute this negative like this, this, and this. So I've got 121 minus t squared plus 36t minus 324. These two combine, and this becomes negative t squared plus 36t, and that is 203. Negative 203. Okay. This does not look very factorable. So wait, let me see. Negative 324. Negative 324. And let me make sure I did that correctly. 324 minus 121. Minus 121. Yeah, I think. Oh, did I say 203? I did say 203. Okay, and it's not divisible by 3. I feel like this doesn't have any factors really, because it's not divisible by 3. 70, 21. It is divisible by 7. Okay, so let's see. 203. Man, these are tough problems. Okay, so it's divisible by 7. And 7 times 29. And these just happen to add up to 36. Okay, so it is factorable, which is good. So I'm going to factor out a negative 1 first. T squared minus 36t plus 203. And then this factors into t minus 7, t minus 29. Okay. So these are the 2 x-intercepts or t-intercepts. Remember I said it went like this, and this is the first point where it crosses at 7. This is the second point where it crosses at 29. The question is asking how many minutes after consumption does the medicine enter the bloodstream? It enters the bloodstream when it's positive, so it's right here after 7 minutes. All right, that is a really hard problem. That's correct. Okay, cool. So there it is. T7 and 29. Boom. All right, excellent. So that is it for today's live stream from Scalar Learning. Hope you guys enjoyed it. Again, if you like what you saw, please click like. And if you want to tune in for more videos like this and more help for the upcoming SAT math portion, definitely subscribe to Scalar Learning. We got weekly live streams every Wednesday. Thank you guys so much for joining. Hope you had a great New Year. Happy New Year. Happy 2018. And I'll see you guys next week. Take it easy.